Good afternoon. This is Becky Brown from 8K Miles, and I'd like to welcome you to Business Transformation with Microsoft Azure Internet of Things. 8K Miles is a cloud and security company. We specialize in providing solutions for our customers that are easy to consume and fill gaps in the marketplace. Today we will explore how the Internet of Things can provide you with the opportunity to enable and extend your business by helping you to enhance the way you connect people, processes, devices, and other M2M assets, and better harness data across operations. Today's panelist is a cloud solution architect for 8K Miles. Mr. Ilyas is a certified Azure solution architect with a deep expertise in designing, developing, and architecting solutions for the cloud. He has worked on many migration and integration projects on Microsoft Azure. Before I turn it over to Mr. Ilyas, just a reminder, if you do have questions during the presentation, please type them in and we will certainly address them at the end. Mr. Ilyas, I'll turn it over to you.
Thank you very much, Becky. Good morning, everyone. Thanks for joining this webinar. So as Becky said, the topic of today's webinar is business transformation using Microsoft Azure IoT suite. So unless you haven't worked or used internet or used mobile, I'm sure you would have come across this term IoT many times, right? And all the IT research firms, analyst firms, all right, predict IoT as a market is going to go billions and trillions, okay? And they predict up to 3 trillion devices and 4 trillion people is going to be connected. 28 trillions of devices and 4 trillions of humans going to be connected in the year 2020. So there are a lot of predictions that comes from different IT firms. So before we get deeper into the topic, let's look at the agenda. Okay, so let's understand what IoT as a definition, and then we'll also look at some real-time, real-life use cases. And we'll also try to understand why cloud for IoT and why Azure in specific for IoT use cases. And then we will also look at some reference architecture, and then we will finish this webinar by key takeaways, by taking some important key takeaways, and then we'll also look at the next steps and the resources you may require to get yourself into Azure IoT. Okay, so this is a typical IoT definition that comes from Gartner, but then if you Google out searching for IoT, right, you will be given with hundreds of different definitions from different vendors and solution providers in the market. And basically, IoT is nothing but connecting various sensors, a network of connected sensors, which gives us internal or external experiences to the consumer or to whoever is interested on. Right? And basically, this data can be used to do two things. One is prediction, and then analytics, and a lot more. Okay, let's put this in perspective. Let's understand where exactly IoT is being used, because IoT as a term maybe it's new, but it's been implemented in many automation industries, maybe automobile industries, in the term called machine to machine, right? So there've been a lot of electronic devices that has been giving us data in many different industries. So in real life use cases, you can visualize IoT, for example, in smart street lights, where IoT can be implemented. Smart sensors can be inbuilt into the smart lights, and then we could understand how the lighting is, how much power it consumes, how long the bulb could last, right? And then we could also use this data to predict how long the bulb can light, how long the life of the bulb can come, right? So there are a lot more scenarios that you can think of where sensors, intelligent sensors can be fixed, and then we can get the data about the internal system as well as the external environment, around the particular object or particular thing. And similarly, mobile check-in, for example. So every one of us, reserve rooms, and basically when you check in, you have to fill a form, and you may need to give the details, and then they will let you in by holding a key. Imagine that you need not do this. As soon as you enter the hotel, if they are able to automatically sense who the customer is, and if they are able to automatically hold the key, right? So you need not really stand on the queue. So there are plenty more, again, use cases on this particular hospitality industry. So IoT can help in many different verticals, many different departments, many different businesses, and especially in the retail system. So retail system can definitely benefit from IoT as a technology. For example, assume that as soon as you enter into a retail shop, based on your past experiences, based on your past purchases, if you are given with a suggestion as to which particular product you may want to buy, right? So probably it will help you to buy the products quickly, and then come out of the store. So again, there are a lot more different situations and use cases that you could think of when it comes to retail industry. So, and these are a lot more industries where IoT can be implemented in smart ways. For example, smart mobility, where sensors could be put into the traffic. So already connected cars are coming. All the BMWs and all the major car makers are getting into the smart cars model of putting the sensors into the cars. And similarly, smart logistics, smart entertainment, and smart building home and things like that. So there are plenty of use cases, and the businesses can definitely take advantage of the IoT momentum. Okay, so we looked at many different verticals where we can utilize IoT as a technology. But before we look at why cloud for IoT and why Azure in specific for IoT, let's look at the three major key parts of any IoT implementation. So the three layers. One is the device connectivity and management, because IoT is all about connecting various devices and how these devices talk to each other, or how these devices give the data back to the consumer, right? So the device connectivity and the management of these individual sensors are hardware, right? So that's the first layer. The second layer is the analytics and operational insights. So once you set the sensor, once you authenticate it, then how do you get the data? How do you find the analytics? How do you make the operational insights? So that's the second layer. And once you also have the data, how do you make sense out of the raw data? Because a typical sensor, for example, let's say your wristband, your health band on your hand, it could send millions of data every minute or every second from all your customer base. But how do you make sense of those raw data, and then you infer the right information of those millions of data, right? So that's where the presentation, the business connectivity comes in. So these are the big three parts of any successful implementation. So now let's look at why Azure and how Azure and cloud fulfill these three important parts. Okay, so the first promise, the problem that Azure as a cloud solves is easy to provision and use and manage, right? So all the services that you're going to see in a moment is offered as a PaaS solution instead of an infrastructure as a solution, right? So as a developer, as a solution maker, or IoT implementer, you need not put together things to connect devices into your cloud services. For example, if you want to collect data from a sensor, you can simply go to Azure and then boot up Event Hub, and then Stream Analytics, and within seconds, you'll be able to get the data and then push into cloud. And when you want to scale the data, right, you can, just like a slider, you can go ahead and add as many resources as you want. So it's very easy to provision and use and manage the cloud resources. And then pay as you go and scale as you need. So that's another promises that Azure Cloud gives you. So when you start less, you start with simpler, very less resources or one resources. And then when you grow, when the user base grow, or when the number of sensors grow, or the volume of data that comes from these sensors grow, you can then go ahead and scale your resources based on the data, the volume of data, or the number of sensors. And then you have global reach and hyperscale. So Azure has almost 19 regions, regions spread across the globe. So if your customer base is across globe, so you can roll out your services very next to your customer, so that there won't be any latency between your customers and the cloud resources. So you can roll out your cloud resources very near to the customers. And then it provides very end-to-end security and the privacy, which is very important in the IoT implementation, right? So these are some of the reasons why you need cloud and why exclusively Azure for any IoT implementation. All right. So this is the complete Azure suite of technologies that helps you to implement a successful IoT implementation for your business. Right from your event producers on the left. So event producers are your your devices or sensors or mobiles, whatever it could be. So it could be IP-enabled devices, or it could be non-IP enabled or low-powered devices or sensors that sit in the field, right? So it could directly send data to event hubs. So we will also look at what event hubs very briefly in the upcoming slides. But event hub is nothing but an event ingestion service provided by Azure. You can simply imagine this as a cloud gateway that receives the data from your sensors. The sensors could be anything again. So it could be your pacemaker that sits within human body, or it could be devices such as cardiac health check device or the blood pressure device. It could be anything. So those sensors data, right? So that could be directly pushed to event hubs if those devices are IP enabled, right? If they are not, then we could then have a cloud gateway. So this is again an in between, a middleware which collects the data from the non-IP enabled devices, non-IP devices. For example, if those devices does not have an IP, if it cannot directly send data to event hubs, then those sensors can then send the data to the middleware, that is cloud gateways, right? And those cloud gateways can then send the data to event hub. So on the event producer side, it could be any kind of devices, whether it could be IP enabled or non-IP enabled or low-powered RTOS devices that can send data to cloud. Okay, and then the ingestion broker. So like I said, Event Hub is a complete ingestion service provided by Azure, which has the capability to ingest up to 1 GB of data per second collectively. And then this Event Hub can then hold the data up to 7 days. 7 days. And once the data, please hold on for a second. I'm sorry. So the Event Hub can then push the data to Stream Analytics. So Stream Analytics is cloud analytic engine which can take the stream of data that comes from Event Hub, and then it can process those data on the fly. So you need not just store the data and then later analyze the data. Instead, using Stream Analytics, you can immediately analyze the data. So once the data reaches the Stream Analytics, you can then push the data to Azure DB or Azure Storage or HD Insight for analyzing the data later in point of time. Or you can then immediately send those data to presentation and action layer such as data analytics or Power BI or web and thick client dashboards. So this is a complete Azure IoT suite, right from the event producers, the ingester, the transformation, and long-term storage and presentation. So it's a complete suite that makes you and helps you to build an IoT implementation end to end. So it's just not that, we'll also look at how the security is handled, how the management of devices are handled in the upcoming slides. All right. So this is the IoT reference architecture provided by Microsoft, so where you can see the devices and data sources on the left-hand side, the data transport layer, where you could either use HTTP or AMQP or MQTT or COAP. There are a lot of open source protocols as well as majorly used protocols such as AMQP, Advanced Message Queuing Protocol, to send events and messages to your event hub or your cloud gateway. Right? So here is the IoT hub. And this is the device and event processing engine, which is the combination of multiple different components within it, such as the event processor, that is event stream analytics. And here is your storage to store the data for long-term storage. And here is the key things such as identity and registry stores, right? So when you have multiple different sensors or hardware, the key problem is how do you identify each of those hardware? How do you authenticate? How do you authorize those independent sensors or hardware, right? So Azure Event Hub helps you to authenticate those sensors using shared access signature. So using which you can uniquely identify these individual sensors and then authenticate it and authorize it, and then you can push those data to the Event Hub partition. So you can either send data to one single partition or multiple partition for a higher scalability. And then you finally present this data to the presentation layer, or you can store that data for a later purpose. Okay, so this particular slide explains you the IoT Hub on a high level. So the IoT Hub and the entire processing engine is still evolving, right? You can find all these content in theory, in Microsoft MSD and articles, but then you may not be able to immediately go and then try to execute it. Still in the cooking stage, right? For example, the identity registry, the device management, provisioning. So these IoT Hub from Microsoft is still evolving, right? But then you can definitely do a proof of concept or POC immediately by hooking up Raspberry Pi or Intel Galileo and using Windows 10, and then you can do a quick POC to find humidity or temperature sensors, and then push those data to event hubs and then to Stream Analytics and Power BI. But then if you have a major multiple sensors, and if you want to interconnect, you may need to look at the open source offerings. Right? So here again, you can find the message comes in. So the message this is your device and the message comes in, and if this is an IP-enabled device, it could directly send to the IoT hub gateway, that is your event hub. All right. So if it is not an IP-enabled devices, then it could either send the data to your self-hosted gateway that's in between your event hub and your device, or you can also use other protocols, the open source protocols such as OPC UA or COAP or all join. So these are some of the open source protocols are supported by Microsoft IoT suite as well. So once that data comes into the IoT hub gateway, then this data can then be sent into the queue, and these, as I said earlier, you could either send the data to one particular partition or multiple partition for a higher availability and higher scalability. So again, so you could see it supports both HTTPS, AMQS, and MQTT, our custom protocol for sending the data and receiving the data from the event hub to the consumer. Okay, so this is a very detailed picture as to you can see how the event producers, your devices send the data to the partitions, the number of partitions on the event hub, and how the consumer groups. So this is your receiver part. So this could be your dashboard. This could be your SQL server, or any receiver who is interested to receive the event that is stored in the event hub. So even you could have as many producers as like 1 million producers you can have, and aggregatedly you can send up to 1 GB of data per second as a throughput. And so your data goes and stores in the partition in a particular order, and then these data can then be received by your receivers. Okay, so like I said, Event Hub is a high-scale, cloud-scale event ingestion as a service. It can handle millions of events per second, and is basically built for telemetry ingestion that comes from the devices, applications, websites, and a lot more solutions. And it could be partitioned consumer pattern where you can start with a lesser pattern. For example, in the portal you can go and you can add up to 32 partitions, but you can also go and request Microsoft to add as many partitions as you want, based on your scale. And then it is SAS-based security per publisher token. So you could either you use one SAS key for many sensors, or you can create separate shared access signature token for each of your sensors and send those data to one particular partition or multiple partitions. Again, Stream Analytics is a real-time analytics engine. So once the data received by your Event Hub, you can immediately analyze the data using the Stream Analytics engine. So you have a sliding window, or a hopping window, or tumbling window, using which you can analyze the data in a particular window time frame. Another benefit of using Stream Analytics is very SQL-like language. So if you're already very familiar to SQL Server, you can immediately use this particular service, and you can use select star from your data. And other key benefit is it's low latency, right? So as soon as you receive the data, when the data is very fresh, you can immediately apply conditions and then look at your data as and when you have the data from your devices and the hardware. All right, so these are some of the common communication patterns identified in the IoT implementation. So one is the telemetry, where the data and the events, the logs push from your sensors to the central server, right? Where there's only one way of communication that comes from your hardwares and sensors to the consumer. And the other is the command pattern, where the consumer or the centralized server sends a command to the sensor to do something. For example, if the external temperature is too very cold, you may want to switch on the AC, or you may want to switch on the heater, right? So that's a command issued from the central server to the sensors or to the hardware, right? The second is the inquiry, where the sensor inquires something to the centralized server. For example, here in this case, if the street light, if the street light is not well, if the condition of the street light is not well, probably it may ask you to switch off the light remotely, right? So it could be some other use case as well. So it's basically sending an inquiry from the sensor to the centralized server. And fourthly, notification, where the centralized server sends a periodic notification to the sensors. So again, you could imagine sending a notification to the sensors. For example, if you have a wristband where your manufacturer of the wristband sends a periodic notification or periodic information about your health based on the data received from your body, right? So it could be some notification comes from the device manufacturer. So one of the major concerns with respect to IoT as a technology is the security, right? So IoT implementation is more vulnerable than cloud applications because IoT implementations involves physical sensors and hardware that's kept away from your perimeter boundary. For example, let's say you have a sensor that's kept in the street lights, or the sensor that's in your wristband, or your sensor that's kept in your cardiac machine, right? So anyone can go and tamper it, or can block the message or hack the particular message, and then they can insert the malicious information that's been sent to the server. So when compared to a perimeter secured application, IoT implementations are very much vulnerable for hacking and for hacking. So it's very important to understand how security is implemented in IoT solutions, right? So just like cloud application, cloud vendors always say, both the customer as well as the cloud provider are both responsible for the security implementation of cloud solution. Just like that, IoT implementation is also very much the same, so where you have to take care of field gateway security, device security, the protocol security, and then cloud provider such as Microsoft Azure is responsible for the security of the data stored in the server, the application stored in the server, right? So here you can basically understand at the bottom most. So on the cloud, the physical security of the OS, the host, and the local network are secured by Microsoft Azure. And similarly, in the field gateways or in the devices, again, it is the responsibility of the manufacturer or the customer to take care of the local network security, the host security, and physical security of those devices. And the global network is again the identity and access and global network is secured by the cloud provider. And then the data and application, data and edge, and data application, the devices side. So it's a combination of security by both the cloud provider, the application developer, as well as the manufacturer of those IoT devices. Okay, so let's look at the real-time use case that we did for a customer in the UK. So our customer is oil and is into oil and natural gas industry, and they lay pipelines across the country. So the gas pipeline goes up to miles and miles. So their requirement was to understand the temperature, humidity, or the acceleration of those gas pipelines within a particular region, because currently they do it by manually inspecting those gas pipelines, and they currently spend millions of money in manual resource to inspect those gas pipelines. So their requirement was to basically understand these humidity and acceleration on a particular region. So we got this opportunity for implementing an automated Internet of IoT implementation for this particular customer. So we basically used accelerometer sensors and then temperature sensor that is fixed on a particular region. And then we also used an IP-enabled sensor which sends the data directly to the cloud gateway, right? So this is again basically for a proof of concept, right? So we fixed around 10 sensors in a given region, given space of the particular gas pipeline, and then we captured all those data, and then sent it to the event hub, right? So the device that we use is our IP-enabled Raspberry Pi-based solution, where it had sensor kept on the gas pipeline to understand and to receive the vibration data as well as the humidity data of the particular gas line. And then we sent this data to Event Hub. So like you see here, so we used Raspberry Pi loaded with Linux and it's an IP-enabled devices, and then the data has been sent to Event Hub, right? So from Event Hub, we then push those data to Stream Analytics to instantly analyze the data. So here you could imagine that we use the hopping window and the tumbling window to understand how much the particular gas line vibrates on a particular region in a given window time, right? So based on that, the customer is able to understand the vibration, how much it vibrates when there is a windy season, and when there is no wind, how is the position and how is the temperature and humidity and things like that. And then for the long-term storage, we then utilize Azure DB, which is the SQL Server as a service, to store all those event data, and then so they can utilize this data to understand how is the past data, the vibration on a given data and the past data and things like that. And then we use Power BI to visualize those data in a beautiful chart forms and visualization. Right? So let's look at some of the key takeaways. So I see questions coming in. I'll take the question at the end of the session. Right. So the key takeaways are, so IoT services suite of Azure are very easy, very flexible and powerful. You need not be a developer to implement a prototype or to get into a production level IoT implementation. So if you have very basic level knowledge on C# or you have SQL Server knowledge, you'll be able to easily pick up Azure IoT suite. And the complete Azure IoT implementation are secure and robust. So like I said, Azure Event Hub implements shared access signature, and you can also use different protocols like HTTPS, or you could go with AMQP or COAP as a protocol to send and receive data from your sensors to the cloud gateways. And IoT can be implemented on any industries and vertical, and especially on healthcare. So healthcare has a lot of potentials to automate many things. For example, a nice use case for you to understand is, for example, you could distribute devices that can send, for example, your cardiac patient data every moment to the hospitals. So the hospital can then visually see how their patients, current, body temperature, something very interesting about their patients. So when the patients come back to the hospital, so while the patient is in the room, the doctor can see the entire data sent by the patient for the last 1 year, 1 month, or 1 week in the dashboard in a nice format. So that gives the doctor the edge to understand how the health of the particular patient was. And this particular data captured can also be matched with the past data of the customer of the particular patient, or it could also be verified, cross-verified with large volumes of other data. For example, if you are validating a cardiac patient's data with millions of other cardiac patients' data, probably you can predict certain very vital information at the right time, right? So you can also use any device using any protocol. So right now there are plenty of new devices are used in the IoT implementation. For example, Raspberry Pi is used, and then Minnow board, and then Intel Galileo and Arduino. So there are a lot of devices that you could use which are IP enabled, and there are plenty of non-IP enabled devices that are also available in the market. So based on your need and based on your availability of the devices, you can pick any one and then try to implement a particular proof of concept for your particular business. And it's a minimal learning curve. So like I said, if you have a very basic developer skill set, or if you have a team of developers, you can very quickly build a POC with the sensors. So it's not zero learning curve, it's a very minimal learning curve for you to get into Azure IoT services. Okay, so these are some of the next steps. So identify specific business priorities in your vertical industry. For example, if you come from healthcare and if you are thinking about automating some business, some processes in your organization, probably you can pick any one or two and then see how you could automate, or you could utilize IoT as a technology to improvise the processes. And look at the Microsoft IoT capability model, and then how it can meet your business goals. And there are many case studies and white papers available from Microsoft and other competitors at this moment. So you could very well benchmark it and how others are benefiting from IoT as a technology, and then build a simple prototype and then see how it works out for your business. Okay, so these are some of the case studies from Microsoft which will help you to understand how others in the business are currently utilizing Microsoft IoT suite for automating many of their processes. For example, Tyrosine Elevator Group. So Tyrosine Group is a multinational company which operates elevator across the globe. So they use Microsoft IoT suite to understand how their elevators are performing, or are there any issues, or are there any potential issues in a particular elevator. So they use IoT implementation, and they built a dashboard using Power BI, which will help them to understand the health of all their elevators implemented throughout the globe. And they will also use that old data to predict the life of a particular elevator implemented for a customer. So there are plenty of use cases, and for example, Allianz Parish, and then Case Permanente, Rockwell Automation. So there are plenty more businesses currently benefiting from IoT implementation. And this is a couple of resources where you can get study materials as well as samples for you to get your hands dirty. And these are some of the specific resources, again, the event hubs and stream analytics. And Connect the Dot is an example built by Microsoft folks for you to get the samples and then build and understand the IoT implementations from Microsoft. All right, I think we are done. So if you have any details, if you want to discuss about any specific opportunity, or if you want us to build a proof of concept for your business vertical, please contact our Director and Vice President, Mr. Tom and Mr. Anand. I think I'm done. Let's look at some of the questions. All right, so there's a question from a member asking about how do they decide whether they need a middleware gateway or should we go with the cloud gateway, right? So it's basically based on what kind of devices or what kind of sensors that you are using for your use case. Like I said, if your end sensors or the product is IP enabled, probably you can directly hook those sensors and devices directly to Event Hub, right? So those devices can directly send the data to Event Hub without any cloud gateway, right? So cloud gateway is specifically for sensors which is not IP enabled, which does not which does not have a way to directly send the data to cloud, right? So where you may need a middleware which collects all the data from the sensors that sits on the field and then collectively send these data to the Event Hub that sits on Microsoft Azure. So it's basically based on the device that you're going to use for getting the data. Okay, so there's a question. Can you share any samples or case studies and white papers on a successful IoT implementation on healthcare? Yes, so there are plenty of IoT implementations or M2M cases on healthcare vertical. There are plenty. So so we will be able to share those white papers and data sheets or case studies to you separately. Yes. Okay. So the other question is, how do you choose between the protocols? How do you choose one over the other? Right. So again, it depends on what kind of sensors, right? What kind is it? Again, IP enabled. So if it is IP enabled, you can either go with HTTPS or you could go with AMQP. But there are slight differences between the protocol itself. For example, AMQP is best for both IP enabled and non-IP enabled, and it's also faster. And there are plenty of custom protocols that proprietary manufacturers use, as well as open source protocols are also existing. So based on your need, probably based on your specific requirement, it is best to choose the particular protocol that you may want to use. Okay, so there's a question. What are the devices supported by Microsoft for building a POC? Yes, so like I said, there are plenty of new devices such as Raspberry Pi, and then Arduino and Mino board, and these are some of the POC prototype boards approved by Microsoft, as well as Intel Galileo is another device. So you could use any one of these devices to do a POC and collect the data. And these devices are available on all the online stores. It starts as less as $30 to $35. You can grab those prototype boards and you can buy the sensors. And it is also available as a package, a complete kit for newbies to get into.
Okay, so how do I scale the Event Hub ingestion is the question. So, so like I said, so you can send the data from your sensors to Event Hub. So while you send the data, you could either send it to a particular partition, or you could send it to a multiple partitions. So when you exceed the limit, or when you throttle, you can go and add as many partitions as you want. So using the portal, you can add up to 32 partitions. But then when you exceed 32 partition, you can then raise a request with Microsoft, and then ask them to provision additional partitions. So you can add the 1024 partitions in the Event Hub. So that way you can scale the Event Hub to your requirement. So there's another question from a member: how 8K miles is related to Microsoft services? Right. So 8K miles being a cloud company, we predominantly work with the major cloud, and especially Microsoft Azure. So we do implementation on the Microsoft technologies, including the VMs, or lifting and shifting of applications, or migrating data centers from on-premise to cloud, or building cloud native solutions, and big data, and then predictive analytics using machine learning. And there are plenty of services that we do on the Microsoft technologies. Okay, so there's a other question. So what are the storage, the long-term storage supported by Microsoft? So the answer is plenty. So you could either send the data to SQL Server, or Hadoop, or you could store it in flat files within Azure Blob Services, or you could then send the data back to Azure Event Hubs. So there are multiple provisions for you to store the data for long-term storage of these events. Right. I think we don't have any more questions. So if you got any more questions, you can directly send email to Tom or ek@8kmiles.com. We'll be more than happy to assist you in any of your requirement. So thanks for joining this webinar. Have a nice day. Bye-bye.